Hi everyone, hope you're doing great. Just here for our last video on covalent bonding. This will be the shortest one. We just have a tiny bit of covalent bonding left. I thought I was going to try to cover ionic and metallic bonding in this video as well, but then I decided it would be best left for a separate video so that I have some more time to go in depth. So the last topic that we have for covalent bonding is called hybridization. Hybridization is another way to describe the behavior of valence electrons around the central atom. In other words, it's like a different way to say what bond angle or what shape is around the central atom, or really what geometry, I should say, is around the central atom of a molecule. Hybridization is actually quite a difficult topic, and it can get pretty in depth. And so a deeper understanding of hybridization is beyond the scope of our course. So that's something that you would learn if you took a college chemistry course, but it is not something that we need to have a deep understanding of here at the AP level. They specifically say in the College Board's curriculum that the deep understanding of hybridization isn't necessarily needed at this level. That being said, they may ask questions about what is the hybridization around the central atom, and we need to be able to answer that. But to do that, it's actually super easy. We just need to use the steric number. And so since we learned to identify the geometry and shape of a molecule based on steric number, hybridization is actually going to be super easy for us. Got this one more time for some reason. Here we go. So hybridization is just based on steric number, and it's super easy. If the steric number is 2, and of course that means that the number of bonding sites on the central atom is 2, then the hybridization is sp. I remember this because 1s, what's happening here? 1s plus 1p is 2, right? Like there are two things, an s and a p, right? So that's why that corresponds to steric number of 2. When it's 3, it's sp2. So 1s and 2 p's would make 3 things total. So that makes sense. When it's 4, it's sp3. 1s, 3 p's would make a total of 4. And so that's where the steric number of 4 comes from. Now, when we have a steric number of 5, that's when we're getting into the trigonal bipyramidal shape or geometry. It becomes sp3d. So, a totally normal question would be, well, why isn't it just sp4 so that 1s plus 4 p's would equal 5? Well, remember, these are actually based off of electron configurations. And so if you remember, when we draw our electron configuration chart, we have 1s, and then in any p level, we have 3 little shells there, right? And then in any d level, if we'd gotten up to the 3d level, we have 5. And so because there's only 3 lines on the 2p level, we can only go to 3 when it comes to p. Can only go to 3 when it comes to p. So after p, we have to move on to d. So sp3d, 1s plus 3p's plus 1d is 5. And then, of course, 1s plus 3p plus 2d's is going to be 6, and that's where we'll get our 6 from. So this would be a chart that you wouldn't receive or anything on the AP exam, but it's also pretty easy to memorize, right? And so really the question will just be, what is the hybridization around this central atom? And the answer is going to be sp, sp3, sp3d, whatever, depending on the molecule that you've drawn. So here's some examples. Here's water, as usual, just gonna knock out the Lewis dot diagram for water. Cool. I notice immediately that my steric number, which is my total bonding sites, my total pairs of electrons around the central atom, is going to be, I think I figured out how to change my color here. That might be helpful. Is going to be 1, 2, 3, 4. And so I have a steric number of 4. That means my hybridization is, let's see, S. I need it to add up to 4. sp3 hybridization. And that's the only question we need to be able to answer about hybridization. What is the hybridization? Okay, and the answer is sp3. Cool. Oh my gosh, I'm sorry. Don't know how to get out of this now. Here's CCl4. We know how to do this Lewis dot diagram. Of course, we're only looking at the central atom, so technically all these valence electrons I'm drawing are irrelevant right now. My T here is going to be 1, 2, 3, 4. I have 4 bonding pairs around my central atom, and that is it. So again, sp3 hybridization. Okay, here comes NO3. Did that again. Remember the NO3 displays that resonance, but for answering the question of the hybridization, I wouldn't need to draw all the resonance structures. I just need to do my total bonding lone, okay? And so, or excuse me, really just my total. 1, 2, 3, remembering that a double bond just counts as 1 bonding site. So I'm not counting that double bond as 2. So that means my steric number on this is 3, which is going to be sp2. So that 1 plus 2 adds up to 3, hybridization. All right, here's a new one. This is carbon dioxide. And so when I do the correct Lewis dot diagram for carbon dioxide, it ends up looking like this. Okay. And we'll see that when we do our steric number, 1, 2. And that's really all that's on that central atom. Remember, these lone pairs out here, they don't count because they're not on the central atom. So I'm not worried about anything that's happening over here. I'm just looking at my central atom. My central atom has 2 double bonds, but every double bond is just 1 bonding site. So my total here is 2, which means this just has sp hybridization. Okay, and then real quick, let's get to this one. P, F, 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 PF5. Can P exceed the octet rule? Yes, because it's in period 3, so it does have space for d electrons, which means it would make this. And then actually PF5 like loads everything up with 8 electrons like this. Again, unnecessary to draw in all of these for just identifying the hybridization, but it is important that you start with the correct Lewis dot diagram. And so I assume in an AP problem, they would have asked me to draw this earlier and maybe answer some other questions. And now they're asking me for hybridization. So it is important to make sure, even though we don't need the lone pairs, it is important to use them to make sure our whole Lewis dot diagram is correct. So once those are correct, I'm just doing my total here, 1, 2, 3, 4, 5. I have no lone pairs. I actually didn't count that one and check it, but I'm pretty sure that is the correct Lewis dot diagram. But if I was being more cautious, I should start by doing my math, counting and checking and making sure this is the correct diagram. My total is 5, so that's going to be, let's see, SP3 is 4 plus the D is 5. And that's how you do hybridization. Okay, so then the very last piece, I was just reviewing the College Board curriculum to make sure that I had covered everything they mention in covalent bonding. And something came up that I realized I never used this vocabulary word, bond order. So we talked a lot about multiple bonds, and bond order is literally just another way to refer to multiple bonds. So here are 3 examples: hydrogen with a single bond, oxygen with a double bond, nitrogen with a triple bond. The bond order of hydrogen is 1, the bond order of oxygen is 2, and the bond order of nitrogen is 3. So bond order just refers to how many bonds there are. It's just another way of saying single, double, or triple bond. So I just wanted to make sure I threw that vocabulary out, so in case we see that word, we don't feel like we don't know what it is. Bond order is just referring to how many bonds we have between 2 atoms. Okay, so 71 slides later, and we are done with covalent bonding. Hope you guys are doing well. Have a great day. See you soon. Back with some ionic and metallic. All right, have a good day. Bye.